All right, one last example today, another system. So we did a lot of linear systems. We did a line with a parabola. Now we're going to throw a circle into the mix. Okay, I don't want to freak you out. The next unit we're going to talk about conics. We'll look at all these graphs. Circles are pretty straightforward though. I know you've seen these before, Algebra 2. So just let me review briefly and then we're going to do something also a little different in this problem. Notice graph the system and find the points of intersection. Well, intersection just where they cross. So that's not hard to do. So let's just go ahead and walk through this. So x squared plus y squared less than or equal to 25. This is the equation of a circle, by the way. I'm only going to give you really simple ones as we begin this, okay? The center is at 0, 0. This is the radius squared, so the radius is 5. So again, I'm just going to give you really nice ones. So centered at 0, 0, square root of this gives us the radius. And so if I go out to 5 everywhere. Now it is less than or equal, and so that means it's going to be a solid line. And again, circles are kind of hard to draw. Let me just kind of sketch it in there. I won't make fun of your circles if you don't make fun of mine. Okay, so less than or equal to 25. Well, if it was greater than 25, that would mean everything outside the circle would be shaded. So less than is everything inside, and so let's just kind of keep that in our back pocket for now. I'm looking for my pencil. I have a pencil right here. So we're saying everything inside, I'll just shade it super light, you may not even see it on the video. So everything inside is shaded right now, okay? If this had been just less than, instead of less than equal, this would have been a dotted circle, okay? So again, same things apply. All right, let's do this second one. Let's get it in the form y equals mx plus b. And so if I subtract my x over, I have negative y greater than negative x plus 5. Let's multiply that negative through. That means we're going to have to flip our inequality, remember. So y would be less than x minus 5. Now notice no equals here, so this can be a dotted line. So our y-intercept's negative 5, so we're down here. And we've got a slope of 1. So if I went up 1 over 1, I'll go make it easy, 5 and 5. And grab my ruler real quick. Let's sketch that guy in. Let's see, make sure I'm doing that right. So negative 5, yeah. Crossing through here, up, okay. So if we go like that, nice dotted line. Now, which side of that is going to be shaded? Well, less than. So we could test. And I guess the circle I didn't, but how could you tell? If you test 0, 0, right? Plug 0, 0 into this. 0 less than 25. Oh, that's true. Shade inside. So how about this one? Let's test 0, 0 as well. 0 less than negative 5. 0 less than negative 5. Well, not true. So this doesn't work, so I'd have to shade the opposite side. So inside the circle is shaded, below this line is going to be shaded. So for my final answer, just make sure you can tell the actual overlap, right? Where do they share that shaded region? Let me make that a little bit darker so maybe the video will show. But I think you can tell where I'm shading, right? So right in this region. And then one last thing, this one asks us that the other ones didn't. Hey, where do they intersect? Well, from this form, imagine this is an equal sign. Okay, we want to go substitute in. So, of course, you can look at the graph. You can probably just tell where they intersect, right? It looks like right here and right here. If you weren't sure, by the way, you could just go substitute in and solve. And so if I took this and substituted it for y, let me just do that over here on the side. So x squared plus x minus 5 squared. I'm just going to do equals 25, okay? We're looking for the x values of where it crosses. And so x squared, let's multiply this out. So x squared minus 10x plus 25 equals 25. Now let's clean this up. So 2x squared minus 10x equals 0. Subtract that 25 over there. And now we could factor, so 2x times x minus 5 equals 0. Where would that be true? Well, x could be 0 or x could be 5. Now you can again look at the graph and you can see that, right? And so then what are the actual points of intersection? Well, it's going to be 0 something and it's going to be 5 something. I just wrote it there. You can see it's 5, 0 and 0, negative 5. Again, you would just plug those in and see what values would make that true, right? So, yeah, not too bad. Just add a little bit to what we've been doing. You may see things like that pop up on the concept check, but I don't think they're too bad for you. Okay, let's finish things up.